Hello, how's everyone doing? Good, I hope. Fred here, AF Math and Engineering. Welcome back, and we are motoring along in our physics mechanics section. We're covering a lot of stuff, and we are finally getting to parabolic motion, okay? So this is going to be, a little bit tricky. Some of you probably did this in high school as well, so this would be a review for you. If not, if you are in high school and you want to take a look at how to learn this, to get ready for university, whatever, then this is the video for you, okay? So this is, this is a little bit of an intro to parabolic motion. And why I say introduction is because we're not going to use the kinematic equations for parabolic motion. We're going to solve this problem in a more intuitive type of way, but it's going to kind of focus on a few key points that I want to point out before we get into the harder parabolic motion questions and some stuff and just some basics that you should know in these types of problems, okay? So this is topic 4. Like always, check the channel description below, or the video description, and there will be a link to our intro video, okay? So the intro video, if you want to be following along with that, we are covering all the topics in physics mechanics first year university, and you can use that to prepare if you're going into university or if you're there now. Okay, so let's take a look at what we got here, okay? So we have a XY plane here, okay? And as you can see, we have some parabolic motion happening here, okay? It's an object, and it's taking this path here, okay? So it starts at 0 seconds, okay? This is 1 second, 2 seconds, and 3 seconds, okay? So as time is changing, this object is, floating through space, and it's subject to some downwards acceleration. Okay, we'll say the downward acceleration is A. Okay, so that's constant acceleration that's being pushed down on the object, okay? Some as gravity, all right? So as you can see here, okay, at 1 second, all right, the object we're given a Cartesian vector here for the velocity. We're not given just a straight, meters per second unit. We're given the velocity in terms of I and j components of the force, okay, sorry, of the velocity of the object, okay? So it's given as 2.0 I plus 2.0 j meters per second, okay? Just so you know. So let's go ahead and take a look at the question, and we'll see what we're asked. So, you're living on a different planet with some constant acceleration. A baseball is thrown in a parabolic motion. At t equals 1 second, the velocity is given as this. Okay, what is the ball's velocity at t equals 0, 2, and 3 seconds, and what is the launch angle of the ball? Okay, so you might look at this and be like, wow, I don't have enough information, how am I ever supposed to know what the angle is here, we just need to know a few key concepts about parabolic motion in order to solve this, okay? So the key points are this. At 0 seconds, okay, with the velocity, okay, is the initial velocity. Okay, so that's going to be the velocity as soon as the ball is thrown. Okay, what is the velocity at 0? Okay, that's the first thing that we're going to need to take into consideration. Okay, the second thing we're going to need to take into consideration is at 2 seconds. Okay, what is happening at 2 seconds? And that's a little bit of a clue for you in these problems. This is the apex of the parabola. All right, so what you also need to know that kind of follows off of that, okay, is that in the x direction, generally in almost all of these questions, the acceleration is 0, okay? So we're not taking into account, wind resistance or air resistance. The ball's not slowing down in the x direction, okay? The velocity in the x direction is constant, okay? So that's something that you need to remember. So this component of the velocity is not going to change throughout this entire motion, okay? What will be changing and what's affected by gravity is the y component of the motion, okay? So the 2j, all right? So what we need to know is that at 2 seconds, okay, the velocity in the y direction, okay, is equal to 0. That's very important, and that always comes up in these parabolic motion questions, is that the velocity in the y direction at the apex of the parabola is equal to 0. So with that information, okay, we can intuitively figure out what the acceleration is, all right? So as you can see, now let's go ahead and start solving this problem. So at 1 second here, we are given the velocity, okay? Like I said, x velocity is not going to change in this question. It's going to be 2, so let's not even worry about that. Let's take a look at the y component, which is the j. So at 1 second, the j component of the velocity is 2.0 meters per second, okay? At 2 seconds, okay, like I just said, the velocity in the y direction is going to be equal to 0 because it's stopping going up and then it's starting to go down. So at that exact point, it's going to be 0. So we know now that from 1 second to 2 seconds, okay, the velocity has changed by 2 meters per second, okay? And that is important, all right? So the change, and I'm just gonna kind of write this here. We'll call that delta Vy, all right? So delta Vy, okay, is equal to negative 2 meters per second, okay? That is the change in the velocity between these 2 points, okay? So the velocity is decreasing as it approaches the apex of the parabola, okay? So that means that if from the 1 second point to the 2 second point, the velocity is decreased by 2 meters per second, okay? And the acceleration is constant, okay? That means that it must have started from 0 at 4 meters per second, okay? So if that makes sense. So if the velocity is decreasing by 2 meters per second, right? So we must have started from 4 meters per second, gone to 2 meters per second, which is what's given, and then gone to 0 meters per second at the top, okay? So intuitively, right, we can see that at t, when t is equal to 0, okay, so we'll just write that when t is equal to 0, okay, the velocity is equal to, and right, the x component is not going to change, okay? We'll say v is equal to 2.0 plus 4.0 j meters per second, okay? And this is also obviously assuming that up is positive and to the right is also positive, okay? So that's, and when t is equal to, and we already we're given 1, right? So what is the velocity at t equals 2? Okay, so we have v is equal to, we have 2.0i, right? X direction velocity is not changing. And we have, as we said before, at the apex, the velocity in the y direction is equal to 0. Okay, and if you could just write 2.0i if you want. You don't need to write 0j. I just did that for you just to illustrate that. Finally, at 3 seconds. So, well, what's the velocity at 3 seconds now? Okay, so we're at 2 seconds, okay, and we are going back down to 3 seconds, right? So we have traveled 1 second, okay? So that means that we have now increased, since we found that the acceleration is 2 meters per second squared, okay? Or negative 2 meters per second squared, right? The change in velocity is 2 meters per second, right? We can now see that at this point, we'll say that's v3, okay? v3 is equal to, like I said before, I is not changing. We are going to have negative 2.0 j meters per second, right? Okay, because now the projectile is traveling in the downwards direction, not the upwards. Okay, but acceleration is constant, so if it changed 2 meters per second from here to here, it's also going to change 2 meters per second from here to here in the y direction. And there we go. Okay, so that's question 1 done, all right? And let's take a look at question 2. Okay, because question 2, and we'll say that this is V0, and V2, and V3. Okay, so question 2, oops, I should probably get these red, so not get confused here. So question 2, what is question 2 asking? What is the launch angle of the ball? Okay, so what we're asked to find, all right, is the launch angle of the ball. Okay, so the launch angle of the ball, okay, is going to be this angle here. So what angle did we throw it with respect to the x-axis or to the ground? Okay, so we'll assume that this is the ground, okay? How far upwards did we have to throw the ball in order to achieve this sort of motion here, okay? And how we're going to determine that is always from the initial velocity, okay? So the initial velocity is always going to have 2 components. It's going to have its x component and its y component. And from that, we can use just basic trig. We can use tangent in order to solve for that angle of the initial throw, okay? So right here, okay, and I'll just translate this over here. We're going to come over here now. Okay, so we have our xy here, right? This is y and x, and we have the kind of the vector here of the parabolic motion, okay? And we have our triangle here, okay? And this is our theta that we're looking to find, okay? So this is going to be our v naught y, okay, and our v naught x. All right, so that's kind of the visual way to understand what this vector representation means in terms of the initial velocity. It's the kind of the visual representation of that. So if we just take a look at this, we can see that opposite over adjacent, taking the tan inverse of that would give us our angle, right? So let's go ahead and just solve that real quick. So we have tangent theta, okay, is equal to, and it's going to be v naught y over v naught x, okay? So theta is equal to the inverse tangent of, what's our v naught y? Well, let's just take a look at our initial velocity. We have 4 here, 4j, right? Because j is our y direction. Okay, and we have meters per second, and we have 2 meters per second in the x direction. Okay, and let's go ahead and solve that. So we should be given a launch angle of, or our theta, of 63.4 degrees. And that is it. We're done the question. So I hope I explained that well. I wanted to do a question kind of like this that's more intuitive versus number-wise, because it kind of helps you think of a few key concepts like I mentioned at the start of the video, like, you know, what's the velocity in the y direction at the apex of the parabola. We know that the x velocity is always going to remain constant unless we're given an acceleration, which in this course will never be given. So x is always constant here. Okay, so anyway, thanks for watching that, guys. I hope that wasn't too confusing. Stay tuned for more. We're going to do some more parabolic motion questions, but we're going to use kinematic equations to solve them. Thanks for watching. Like and subscribe if you enjoyed the video.